Experiment number 6. Conditions of equilibrium. In this experiment, we will get to know how to apply equilibrium in practical ways, with all data, observations, and the conclusions that the group has been provided. So, let's get started. Objective. The experiment aims to find the equilibrium force using the force table and apply the conditions of equilibrium in verifying the magnitude of forces and torques acting on a stationary beam carrying a load. For this experiment, you will be needing 1 pieces aluminum beam, 2 pieces of loads 500 gram and 250 gram metal bars, 3 pieces of captured thumb screws, 3 pieces of hex standoffs, 2 pieces of table clamps, 2 pieces of multi-clamps, 3 pieces of steel rods 120, 90, and 45 cm, 2 sets of force sensor with USB link, laptop, force table, 4 pieces of super pulley with clamp, 4 pieces of mass hanger, 1 box of set of masses, ruler, and protractor. Let's go now to the procedures. This experiment is divided into 2 parts. In part 1, here are the procedures. First, set up the force table and laptop. 2. Launch Data Studio, display digits, increase precision to 2 decimal places. Set up force sensor to force pull positive. 3. Set up 2 forces. 4. Determine the equilibrium experimentally by displacing the central ring of the force table. 5. Calculate the equilibrium force using analytical method. Compare it to the measured value and find the percent difference. Part 2. First, set up the apparatus. Second, press the 0 buttons on both force sensors so that the weight of the beam will become negligible. 3. Measure the mass of the loads. 4. Place 1 load on top of the beam on the position indicated in the table on data and results and click Start to have measurement of the forces. 5. Replace the load with a heavier one and repeat procedure number 4. 6. Compute the percent error. Observation. In static beam, both of the sensors A and B are not balanced, which is the initial. We observe that every position of the loads in the aluminum beam has different measurements based on the computer. In the force table, every mass hanger that are connected to the super pulley has different loads that made the ring has its tension. Every super pulley have different angle and have loads to make the ring push the pulleys. We observe that the greater the mass of the hanger is the more difficult for the ring to place it to the center of its original position. After we done our experiment, we conclude that the higher the mass of the object's force exerting is, the same amount of force you need to be exerted for it to be equal or balanced.